You may have heard that using AI is an environmental catastrophe, that every time you do, you're burning up through a bunch of water, using a lot of energy, and that maybe you should feel guilty for using it. This mattered enough to me because I work in the ecological space that I actually paused using these tools until I was able to do enough research to determine whether that was accurate or not. That's what this video is about. I'm going to go through the actual ecological footprint of AI, not the industry hype, but not the doom either. Hi, I'm Mike. I've been in the ecological field for the last 15 years and do not come from a technical background. I'm going to share what I found in plain terms, and I'll give you the verdict now. With intentional use, keeping your judgment intact, you can use these tools in an ethical, very effective way that really keeps your footprint small. At the same time, people in our space need to be a part of the conversation about that infrastructure build out because we're well suited for that. Now let's get into it. And I'm going to start with the part that no one should soften, and many of you have already heard much about this, and that is AI uses a very large amount of electricity. Now, if you've watched my other videos, you know that the pace of this technology, the improvement, the efficiencies, all of these different things are growing and moving incredibly quick. That makes it very difficult to actually give you an accurate description or a snapshot of what's happening, because by the time a report or an analyst or a paper comes out on this, the technology's already changed. It's already grown in scale, but it's already changed in efficiencies and all these different things, and it makes it hard. But what we can do is we can look at the patterns. We can look at the trends and the scale as that goes. The Lawrence Berkeley Lab, which is a Department of Energy lab, can show a trend over in less than a decade. In 2014, U.S. data centers used about 58 terawatt hours of electricity. By 2023, that number had grown to 176 terawatt hours. That's almost triple use in under a decade. And they estimate that by 2030, it's possible that U.S. data center usage could be over 11% of the national energy use in the United States. And it's not just energy. Water is part of that environmental footprint too. That same Lawrence Berkeley Lab report said in 2023 that these data centers were using about 17 billion gallons of water, and that could double by the end of the decade. Now, one thing worth noting is that the efficiencies of water use and energy use have improved since then. I'll go into that in a minute. But that shows you how quickly this build out is occurring and that there is a real and problematic environmental footprint to all of it. So if your instinct was telling you, hey, there's a really big environmental footprint of AI, you're not wrong. There is a real problem with this, and that's something that we go into. But here's something that digging even further into that told me about what these numbers actually represent. Because every number that I just gave you describes the whole industry, not you just sitting at your desk, text prompting along with AI. And that's a different story. So let's start with what these numbers actually represent. First, data centers aren't just this big ChatGPT or Claude machine. They represent the back end of a lot of different kind of technologies running in that space. That digital world includes cloud computing, which makes up over half of the traffic that passes through a data center. And then you have industry and legacy and enterprise software, you have gaming, you have streaming, and a smaller fraction of that is AI. So AI does have a footprint. I'm not negating that, and I'm not saying that that's not problematic. We get into how do we make that footprint less, but it is a smaller part of a large infrastructure. Now, one of the challenges of having this conversation is that there's no clear delineation of what is AI traffic and what is cloud computing traffic. There is only estimates because a lot of these processors and servers serve multiple functions in multiple parts of the industry. And it's also worth noting that AI is the fastest growing part of that infrastructure. Now let's talk about the part that actually is AI. When people say AI uses a lot of electricity and a lot of energy and a lot of water, they're not wrong, but what they're also doing is clumping a bunch of different activities under one word. And I think it's important that we pull those apart and see, are there parts of AI that are really driving a lot of that energy use, that part of the pie that is AI? And are there parts that we can use that are very helpful, that are force multipliers that can increase our positive impact that we're trying to have and minimize that footprint that we might have doing so? And again, there's no specific numbers that we can point to and say this is the percentage of use. But we can look at the scale of use and see where our use cases would land. So up at the top, the really energy and water intensive uses are things like training a new model. When you hear the term LLM, frontier model, large language model, Claude, Gemini, and ChatGPT are the big three And those LLMs, those frontier models, are all those models that we see consumer facing. There are other ones, but those are the big three. So I may use those interchangeably. Every time they train a new model, it takes literally tens of millions of hours of special processing time to train that model. Now, they only train that model once and then they release it, but they're releasing new models every so many months. And training that new model can cost tens of thousands of metric tons of carbon. Those are the numbers that are making the headlines, as they should. Those are huge numbers. And that's an area that needs to be addressed on how we approach that moving forward. And then a little further down the spectrum, you have the enterprise AI, agentic AI software use that's going on in the background there, using large amounts of that data center traffic. You also have medical field and academic research going on. That's significant, the data science level. And then as we start to go a little lower, then we start to get into the areas that we might, as consumers, be using this. And towards the top of that is video generation. Video generation using AI does have a significant footprint. Not like training new models or the research or the enterprise level software and AI, but it's significant. And then you get down to image generation. And then down towards the bottom is that text prompting, the going back and forth. That's the area that I'd like to focus on. For me, that's where I use the most. 99% of what I do with AI is in that realm. And that footprint is very controllable. It's small to start with compared to the other use cases. I'll go into that in a moment, but it's also very controllable. And for me, has the most significant return on that investment. So let's put our use cases in relative terms to one another. Now, while we don't really have a reliable statistic on how much energy gets used in video generation, it can be hundreds of times more or even thousands of times more energy use for generating a 10-second clip of video than a text prompt. And then when we look at image generation using AI, now we're dropping down to the energy use that is equivalent to charging about a quarter of your cell phone battery. And then down at the bottom, text prompting, that is about 1/40th of the amount of energy as it takes to charge your cell phone. So 40 text prompts back and forth could be the equivalent of what it takes to charge your cell phone. To put that in other relational terms, if a text prompt is maybe 1 or 2 steps, then an image generation, that amount of energy is walking across the room. And then if you're going to use that same analogy and carry it to video generation, then you're walking a city block or two. That is the difference in scale as you go up. That doesn't mean you can't generate video. That doesn't mean you can't use it for generating image. What that means, though, with intentional use is, hey, if I'm going to need some video, is there some kind of stock image or stock footage that I can use instead of trying to generate it myself? Now let's go more in depth on that text prompting, because that is really where I think the value of this is, and that is where I've gotten a great deal of value for a very minimal footprint in my own work. To look at how text prompting can be a minimal footprint in another way, at scale, the International Energy Agency looked at what would happen if every single web search, every single Google search in the entire world were actually a text prompt query. How much energy would that use? Everyone around the world. And it would be less than 4 terawatt hours. That's less than 1% of data center usage. Now, don't turn that into a statistic. I'm not saying that text prompting is using less than 1% of the electricity. That's to say, at a scale, if every query of a Google search turned into a text prompt query using the right model, and I'll talk about that in a moment, that would be less than 1%. That is how much intentional use with AI can have a low footprint. What it does tell you is that your text queries, relative to the rest of the system, have an incredibly low. And especially if you're using the right tool, it can become a rounding error by comparison to the rest of the industry. It doesn't mean we still don't control our footprint, but by controlling our footprint becomes very, very minimal. Now, there is an exception that cuts across the easy version of this, and that is thinking mode. Now, I go into the model selection a little bit, but each of these vendors also have thinking modes within their model that takes more time. It thinks through a problem step by step by step, and does reasoning in the background and checks its work a little more often. Now, that's helpful and a reasonable use if you're working through a difficult problem. However, you don't need that high reasoning model to draft a 2-sentence reply of an email. And this is where intentional use becomes an actual environmental choice rather than a technical choice, because those reasoning models can use up to 97 times the amount of electricity as the simple text prompt. So we've established that the footprint per text prompt is pretty small. The next reasonable question is it getting smaller or bigger over time? And it's both. Some of the research that I came across that helped justify me picking these tools back up was the amount of efficiency gains that are occurring in the space. Google has reported that the efficiency in prompting in text has improved by a factor of 33. Not 33%, 33 times more efficient within just a year. Now, these are Google numbers, so you have to take them with a grain of salt because they're inside the industry. But they're suggesting that now your simple text prompt is about the equivalent of running your television for 9 seconds. But what about the statistics and the data and the research coming from outside of the industry? Research by the International Energy Agency is showing that the amount of energy used per AI usage is dropping by an order of magnitude annually at a minimum. And research out of the University of Michigan shows that at the chips from this generation compared to the last generation are using about a third of the energy than the previous ones. Now, I said I'd get back to models, and here's the part that matters to you. Each of these vendors, Gemini, Claude, Chat, they all have different levels and different tiers of models within their own ecosystem, from smarter but also higher energy use to easy, fast, and less thinking, less processing time for your easier answers. And Barros et al. Found that if everybody worldwide just used the correct model in their text prompting, we could reduce the amount of energy used in AI by 28% at that level. Now, it's worldwide, but just by using the right tool for the right job, 28% decrease in the amount of energy used across the planet. What do I mean by that? Well, let's use the analogy of going to get a bag of groceries. You could hop in your car, go to the grocery store, get a bag of groceries. You could do the same thing with a fully loaded semi. You would get the job done, but you don't need to. Using that extra energy, that extra power isn't necessary. The same with text prompting. If you're drafting an email, reformatting a spreadsheet, you don't need to go to the smartest, highest functioning frontier model. You can use the cheaper, easier, faster model to get the same job done. Complex problem, yeah, go use the tool that you have to, but for those simple problems, use the right tool for the job. So that brings me to the next question that I was asking myself is, okay, reasonable use, but compared to what? What is the human equivalent if we didn't use AI? Because the cost of not using AI is still not zero. The work needs to be done, and that work still comes with a cost, whether we use AI or not. We have to commute to the office. We have the lights, the equipment running, the HVAC. Tomlinson et al. Decided to study this. They wanted to look at how much energy is used between AI generating a page of text versus a human generating that same page of text. What they found was the AI page of text was 130 to almost 1,500 times less energy than humans generating that same page of text. And when it came to generating images, that spread was even wider. Now, two things. One, I am not advocating replacing people with AI. That happens in the corporate world, and that's one, a problem and one we need to address head on as a society, because that is going to be a growing problem. But when it comes to the environmental field, I feel like instead of using that to, as they say in the corporate world, reduce headcount, we already have our budget. We have our team. We could take that team, use these tools and leverage them and make that team of one person, for me as an example, 5 people, 10 people, 50 people, and we can take that and increase the positive impact with a very minimal footprint. So that team of 5 people becomes a team of 7 people just by leveraging AI, the tools. The other thing that you need to note is that's just comparing the task to the task. That's not comparing the entire workflow of getting to generating that page of text versus humans doing it, or the entire workday. Because there are certain things that AI can do well, there's other things that it can't do well, and there's other things it can't do at all. And the authors of the paper pointed that out as well, along with the Notre Dame research that came through with importance of work for us. And that's a whole other conversation that I'm not going to cover here, but I'll boil it down to this. Just because AI can do something doesn't necessarily mean it should. There's certain parts of our work that we want to keep ours because they're important to us. And again, we're not looking to replace humans. However, when we're looking at footprint and looking at, hey, can we justify using these tools? Let's look at what it cost for an entire year of AI heavy use, because there's research done on this. That entire year of heavy daily AI use comes out to less than usually 10 kilograms of carbon. So while not replacing the human, augmenting the work of the human being with the AI tools has a minimal increase in carbon dioxide, minimal increase in water. Meanwhile, that positive impact can be significant and an outsized impact for a minimal footprint. And for any of you that may still be sitting the fence and not quite sure on this, my goal is not to push you into the tool. Although I feel like having the tools in the hands of environmental practitioners can really help improve the impact that we have in the world. But think of this. You drive to sites. You use computers that have rare earth minerals mined, maybe the batteries from lithium mines, and we know that those sectors have a negative footprint. We still use the tools. The option really isn't just to work by candlelights, don't leave the house. We do what we have to do. We make the best choice we have and fight to make the system better. And I feel using AI is the same. Use the best tool in the best way we can. Meanwhile, fight to make that infrastructure system better. And that's what I get into next. Because while it's nice and tidy to say, well, the tool's footprint is small, you can make it smaller, the efficiencies are getting better, go in peace, use the tools, no problem. Well, the problem is this infrastructure build out is increasing that speed, and that speed is outpacing the efficiency gains. The International Energy Agency showed that data center growth has grown by 17% in the last year, and about half of that was driven by AI. So how do I square both of those sides? Your text prompt's getting smaller, we can use the tools, and this big data center growth is happening. Well, like this, because one, that data center growth is the entire digital ecosystem. Cloud computing, enterprise software, streaming, gaming, and AI, which is rapidly growing. So I'm not negating that, and I'm not trying to minimize that, but I am trying to put that in context. And that's why I feel this needs to be two different conversations. There's the conversation of your footprint, relatively small, controllable, and getting smaller. And we need to be actively seeking with intentional use, and I talk in a later video about how to do that, to do so. And then the data center and the infrastructure growth. Large, heavy environmental footprint, and it's landing in communities that often don't get a voice, while being controlled by a very small handful of individuals. And it's that conversation that not only do you have a right to be a part of, I feel you need to be a part of. We all need to. I was in West Virginia yesterday talking to a watershed organization about this very thing, because we need as communities to start having those conversations now, start building the relationships and figuring out the plans now, as opposed to when an application actually lands on someone's desk. And we in the environmental space are very well suited to have that conversation because we understand what an environmental footprint looks like, not only in the immediate term, but in the long term. We know how to mitigate some of that. And when it comes to having a fight against somebody with deep pockets trying to put infrastructure where it does not belong, this is nothing new to us. We've had that fight with other industries. We continue to have that fight with industries, so we know better than many how to navigate that. So if you have questions on how the infrastructure gets built, where it gets built, and who carries the cost, and that's what brought you to this channel, hang out, because that's where we go in our next video. Thanks for watching.